Hello and welcome to A1 injection tutorial. A1 injection flaws such as SQL, OS and LDAP injection occur when untrusted data is sent to an interpreter as a part of a command or a query. The attacker's hostile data can trick the interpreter into executing unintended commands or accessing unauthorized data. There are different types of injections such as command or OS injection, SQL injection or SQLI, XPath injection, JSON injection, LDAP injection and many more. We will discuss SQLI, command and JSON injection in detail. Let's consider SQLI injection. Consider an attacker, a web server, and a database. The attacker tries to inject the SQL statement into a text box which goes through the web server, and due to lack of validation in code, the injected SQL is automatically executed by the database, leading to tricking the interpreter into executing unauthorized data. Now let's consider an example of SQLI. Suppose there is an SQL query like this. 1 equal to 1 attack is any kind of totality of truth. As long as any kind of this statement is true, it can be used in this type of attack. Dash dash is a way to comment out the remainder of the statement. This is usually going to be syntactically specific to the type of SQL database that has been run on the backend. Sometimes the attacker will purposefully put in the SQL injection attack hoping to receive some sort of error message that indicates the type of database that is actually running. That helps them to construct or craft their SQL statement better or specific to that type of database, whether it is Oracle or MySQL, etc. The result of this query, when executed, it will divulge full disclosure from the users table of all the users' IDs and their passwords. Command injection. It is similar to the nature of SQLI, but it usually occurs due to immediate execution of arguments received. For example, if we immediately pass the received argument parameter into our execution function. Now the problem here is an attacker can maliciously place a command that will allow an attacker to have escalated privileges on the actual machine where the command is being executed. JSON injection. It is difficult to focus on any one particular type of JSON injection, so we are going to just take a look at the receiving of untrusted data and how we can protect our application from that data. So in this example, we have exclude sanitized user input from format strings. We basically have in the package class of Java IOStream two formatting methods, format and printf. Now realize that system out and system are print stream objects that are very commonly used across Java applications. The point here is that if untrusted data is incorporated into a format string, it can actually lead to information leakage. We are going to see an example of that in a moment. Input validation is to be added in our code in order to ensure that we are only receiving only acceptable values and not untrusted data. So let's take a look at an example. The sample code here, there is a non-compliant code example that can leak information about user's credit card, specifically about the expiration date in this particular code snippet. So if we have this class format and inside that we have a static instant, the received parameter is compared to the date and leakage occurs. So due to the absence of proper validation, the expiration data was leaked in our example. In order to address this problem, what we need to do is exclude any untrusted user input from that format string. Here we are no longer allowing the display of sub-zero. We basically render that payload attack. We have the same code here, but the only thing we have changed now is that format method of our system out. We only display %s. So whatever gets passed in our sub-zero is actually then displayed via %s format instead of being displayed directly as what was presented in this parameter. So even if our attacker were to supply something that would cause information leakage, the result would just echo back the same value instead of leaking the month as it did before.